Okay, we have a quick integral today. We've got the integral from 0 to 1 of x squared plus 2x plus 3 over x cubed plus x squared plus x plus 1 dx. Okay, to get started with it, I think I want to just factor out this denominator and see what happens. And there's probably different ways you could do it. What I want to do is, looking at this right here, I can factor an x squared out of this and write this as x squared times x plus 1. And then we'll just kind of group the last two terms here, x plus 1, noticing that now that we have x plus 1 in common. So if we factor that out, what we end up with is x plus 1 times x squared plus 1. And so now let me just rewrite this with the denominator in this form here. And what I want to do in order to avoid the partial fractions is I'm going to try to force cancellation to happen without even worrying about what the real numerator is. We're just going to kind of put this in and hope it works. So now we have this set up where if we break it into two fractions, two integrals, this term's going to cancel here, this term's going to cancel here, but we need to see, did we change the expression? If we add up this whole numerator, we get x squared plus x plus 2. Well, all I need to do, if I actually multiply in a 2 right here, now when we do it, that's going to match. Now we have 2x, that's going to match here. Then you distribute it in, we get here a 2 plus 1. This gives the 3, and so now it's going to work and we haven't changed it. So now I can split this into two integrals, just breaking it up on this plus sign right here. And now from here we can cancel x squared plus 1 on this one over here. And then over here we can cancel out x plus 1s. But now we basically just have two easy integrals. The first one, this is just going to be natural log absolute value, but because our bounds are always positive, I can drop absolute value on this. And then let's put them together so we can evaluate it all at once. So then 2 we could bring out as a constant. This is going to be plus 2. And what's left is just going to be 1 over x squared plus 1. That's just going to be our arctan formula. So this is going to be arctan of x, and the whole thing is going to be evaluated from 0 to 1. Plug in 1 on this, we get natural log of 2 for this part. 1 here, arctan of 1 is just pi over 4, so we're going to have plus 2 times pi over 4. And then plug in 0, what's going to happen? This is just going to be natural log of 1 when you plug in 0 there. Arctan of 0 is just 0. But ln1 0, so this whole thing here goes away. And cancel a 2 with a 4 here. And so putting it together for my final solution, we just get natural log of 2 plus pi over 2. And that's it. Okay, that's all I got for today. Thanks everyone for watching. Have a good day.